Thank you very much for your kind introduction. My name is Masahito Kamori. I'm a project professor from Keio University in Japan. And I'd like to present textile wearables, especially from the Japanese landscape situation. So textile wearable sensors, textile manufacturers are now introducing smart textiles into the market. These smart textiles can be used as sensor devices to collect biodata, such as temperature, heart rate, EEG, EMG, and so on. And smart textiles enable textile wearable sensor devices and expected to open many new applications and services, which I will touch upon briefly today. And some of them are already in use in the market, especially for monitoring health level and workplace safety, and also other trials, such as for athletic training. And I would like to introduce briefly what happened a few weeks ago in Japan. There was an event called CTEC, Combined Exhibition of Advanced Technologies, which is an annual trade show in Japan. It is regarded as the Japanese equivalent of Consumer Electronics Show in the United States, CES. It is Japan's largest IT and electronics exhibition and conference. And it was held on 4th through 7th of October this year, just last week, actually. Yeah. And CTEC provides a platform for companies and organizations from all over the world to showcase their cutting-edge products, services, and technologies, especially from, of course, Japan. So this is how it was in last year. So it looks kind of like CES, if you know, if you've been there. And it so happens that there was an event organized by the Japan Chemical Fibers Association, which was titled Advanced Textile Materials That Contribute to Smart Society, which was held on the 5th of October. And there were two companies, Toray and Toyobo. They presented their smart textile garments using textile wearable sensors. One is from Toray, titled Wearable Sensing Device HITO that allows biomonitoring by just wearing garments. And the other is Smart Textile, Bioinfo Measurement using Smart Sensing Wear by Toyobo, which is another big fabric company. And this event demonstrated that the textile industry as a whole is promoting textile sensors as a promising area of their industry. So I'd like to go on to the explanation and description of these two presentations with materials from other sources. HITO is Toray and NTT, which is a telco in Japan, and they collaborated with each other to develop this textile wearable sensor called HITO, pronounced HITO, which was developed in 2014. And it's supposed to be the world's first textile wearable sensor. It is made up of nanofiber, whose width is 1/7,500th of a human hair, so which is very, very thin. And this fabric is combined with conductive material to make a sensing device, and which can have very close contact with the skin. So I'll show you a brief demo, a video explaining this HITO.
Some of the world's best solutions start with the most challenging problems, and the new HITO material from Toray is no different.
もともと私は外科手術をしていたんですけれども、救急の到着をしているときに患者さんが搬送されてくるんですけれども、中には心臓が完全に止まってしまっているような方がいらっしゃることがありまして、何もすることがないというふうな悔しい思いをしました。深刻なことになる前に、病気を見つけることができれば、このようなことがないんじゃないかというふうに思って、肌に優しくて負担のない繊維の電極を開発しました。
In a unique partnership between Toray, Japan's largest synthetic fiber maker, and NTT, Japan's top telecommunications company, they work together to invent a functional textile embedded with sensors that can monitor the human body.
今回 NTT さんで一緒に仕事をして、我々の材料を新しい方に使ってもらえる、これはとても楽しいことであり、我々にとって必要なことであるということで、とても今回有意義なコラボかなというふうに感じました。
What made this project stand out was that the sensors had to be embedded as an integral part of the fabric. That's why they call this wearable technology HITO, Japanese for one layer. Not only did the fabric have to conduct electricity from the sensors to the transmitter, but the garment had to be robust and washable.
ヒトレに使っている素材がナノファイバーなんですよね。ナノファイバーをこのヒトレに使うっていうこと自体が非常にチャレンジングだったというふうに思っています。
Conventional polyester fibers only touch the skin at relatively few points. Toray provided a solution by using innovative nanofiber manufacturing technology, employing polyester nanofibers, each almost 100 times thinner than a human hair, as the base material for the fabric.
ヒトレというのはですね、テキスタイルなのでいろんな形に変えられます。さらにはいろんな信号を取れます。それによって、我々のモードを加えると、ヒトレというのは無限の可能性を持つ技術だなと。ぜひそういった部分を今後皆さんに利用していただけるように我々としてもよりサービスを提供していきたいと思っています。
The most obvious use of HITO is still the reason the technology was developed in the first place.
ヒトレのような素材ができてきますと、体の中の情報を自然に取り出して、しかもいつでもそれにアクセスできるようになってきますので、例えばこれは私の心電図なんですけれども、メディカルチェックをいつでもこうやってできるようになりますし、例えばエモーショナルなワクワクしたりドキドキしたりするような情報をシェアすることが簡単にできるようになるかもしれません。
Find out more about Toray's world-changing innovations at toray.com.
Okay, so this is introduction by Toray, and this is the original video, so it's actually a little old. So now they said 150th width of human hair, but now they developed up to, down to 7,500. So it's very thin, and this is the look and feel of the actual garment. And so the garment itself, it's kind of hard to see, but it has a transmitter and also sensor is actually embedded inside. And there's smart garment bras for women. So not only for men, but also for women. This was introduced in 2015. And this is the original design of HITO garment. So this is the sensing device, and this is the wiring. And then this is the fabric that attaches to your body. And then there is an interface for the transmitter. But now the current design is a little different. Now they have the transmitter in front, but the wiring and the sensor is on the back. That's probably because it's stable on the back side, but front side you move your muscles and things, and then the contact is lost, and there will be a lot more noise. So the positioning and wiring has developed a little. And this is the the actual fiber. So the whole shirt itself is not a sensor. There is a sensing device made up of this nanofiber, and which is just set on the back side. And this sensor is actually an electrode, and it's made up from combining nanofiber and conductive polymer called PEDOT-PSS. I don't know how to pronounce this, poly-3,4-ethylene dioxyphene polystyrene sulfonate. And it has a very high electricity conductivity and also durability. So it is very suitable as a wearable sensor. And it has the capability to have a very accurate measurement of biodata. And it's a high affinity with water and sweat, which provides comfort in wearing the textile. This is a very important point because when you have a textile wearable sensor, clothes and garments are worn for many hours and you have to wash them. You can't throw them away. So then how can smart textile remain electrically conductive after worn and washed? Usually when mixing the fabric with conductive polymer, it's not enough to ensure this conductivity because with textile made of normal polyester fibers, large gaps exist between fibers. And then the conductive polymers get easily taken out after the fabric is worn or washed. So this was a challenge that they had to cope with. And in HITO's case, they mix the electricity conductive polymers, enter and fix themselves in a position within the gaps left between the nanofibers. So they're not separated, but it's embedded. So that's how the conductive polymers don't get separated so easily, but stay on the fabric even after it's been worn for many hours or washed several times. Actually, it doesn't stay on forever. It's like you can wash, I think, up to 30 times, but not so, not too many times. So, but I think the situation has improved a little, but up to 90 times, 30 to 90 times, you can wash your garment. And this is the transmitter for HITO. So just as I said, it's attached in front with the interface. So with sensing device, with the fabric sensing device, and this transmitter device, these will enable the continuous collection of heart rate, EEG data, EMG data, and so on. And the collected data can be sent to, for example, a smartphone. Most of the applications that we have use smartphones. And the data can be analyzed not on the smartphone, but on the sender side. So, and also an important part of this application, many of the applications is visualization of changes in physical conditions as well as emotions. We will take a look at them later on. And an interesting case is a comparison between HITO and other wearable sensors. One is electrolytic fiber. And there are some fibers that are electrolytic. As I said, they don't have enough contact with, or stable contact with the skin surface, or durability that's necessary for continuous wearing. And usually we have more noises. And we also have conductive paste that can be attached on your skin. But as you can imagine, you can have rash when you have paste on your skin directly. So this also implies difficulty in long-term use. And Toray claims that textile has an advantage over watches and wristband in long-term use, but this may be questionable. Maybe it's a good discussion point. in the later discussion panel. And HITO also is claimed to be more suitable for long-term wearing. Again, this might be an interesting case for debate. The current usage of HITO is primarily for personal uses, and they are, as I said, usually combined with Bluetooth LE and smartphones. And typical data that are collected are heart rate, EEG, EMG data. And there, Toray is working with NTT to provide cloud-based development, which started in 2016. And one example, this is actual use case of Toray, is monitoring at workplace. They monitor workers at a workplace, such as factories or construction site, and they collect data about heart rate, body acceleration, GPS positions are continuously monitored and transmitted to the cloud so that the manager on the data center can monitor them. And the data is analyzed and reported back to a management center. If there is any outstanding issue, for example, there are certain limitation or threshold on the data, then the manager can call the workplace and talk to that worker and check whether he's doing okay. So this is the scenario. So this is the workplace. And you have HITO sensor and smartphone and transmitter. So they work, and while they're working, their heart rate, acceleration, GPS position are continuously transmitted to the cloud, and then the information is analyzed and then reported back to the management center. And then the manager can monitor using the tablet. And the tablet itself is a sort of an application that tells you whether a certain data or the figure is stable or not. And if there's anything, if the value goes over the threshold, alert mail is sent to the manager, and the manager calls the workplace and checks the workers. So this is the scenario, and they're actually using this for their factories. And this workplace monitoring is done using the following collected data. One is heart rate, and then heat exposure level, using the criteria is given by the Ministry of Health, Labor, and Welfare of Japan. And then work intensity, which is calculated using the method called Karvonen method. And then emotional stability is also collected or calculated, which uses interbeat interval, which RRI. If the RRI is short, then that means this is stress. But if it's long, then that means he's relaxed. And fall, of course, there's an acceleration sensor for the fall detection. And then energy consumption is calculated using the equation proposed by American College of Sports Medicine. And lastly, position of that particular worker is calculated using GPS of a smartphone. So this kind of workplace monitoring has been in use and test beds in several different situations. One is major airline company, I don't know which one, but probably All Nippon Airlines or JAL in Japan since last summer. Also construction company and Toray factories, they're actually using this monitoring system in their factories since last summer. And they're expecting to do more with their own factories as well as other sites and municipalities. And they're expecting to provide this for drivers and office workers as well. They think they can use this technology or system for monitoring of health hazard of a small group of workforce in a potentially danger-prone workplace, such as I said, heat exposure, and also in offices. You can manage workplace against excessive workload and mental health problems, if the worker is not stressed or in hospitals. In Japan, aging society is a big problem now, and there are lots of pressure on the healthcare workers. So by using this kind of monitoring system on the elderly people, we can lighten the workload of healthcare workers, and also early detection of health hazards. And so this is the actual use case. This was the actual use case of the Toray. There, again, as I said, NTT Group co-developed HITO with Toray, and they are applying this system in different scenarios. One is the monitoring of athletes. So NTT West, which is one of the subsidiaries of NTT Group, is using HITO to monitor physical conditions of athletes. And this is targeted at training for Tokyo Olympics 2020, which is an obvious target. And visualization of the conscious use of body functions and coordination is the main target of this training. So this is the picture that they presented. This is a soccer football situation. There are two gateways to monitor, and they provide the application to analyze. This is the gateway they actually showcased in CTEC, and this is the HITO garment. Another one is IndyCar series. I will show the video. They did the experiment. NTT Data is another subsidiary of NTT Group, and they worked with Chip Ganassi racing team and Tony Kanaan, and they monitored Tony Kanaan's performance during Indy 2015. And as you can see that Indy car drivers ran at speeds up to approximately 378 kilometers per hour, and they sweat a lot, and they move a lot. So the calculation of the positioning, EEG and EMG had to be filtered to eliminate the vehicle vibration and all the other noises. So I'll show you the video.
With NTT, we're developing new things. We're always trying to create new boundaries.
Partnership is an easy term to throw around. It's difficult to turn partnership into true success and have trust behind it.
On the racetrack, in order to win a race, there's pit stops, there's car setups, there's so many factors that are involved in the performance of the cars, and NTT Data provides a platform to gather the information and analyze the information for us.
They collect over 200 different pieces of information from all over the car, but they don't collect any information from Tony himself.
We'll be developing this shirt that tells live in the pits heart rate. The one thing that fascinates me the most is that we're probably going to be using that in hospitals in the future for people that are recovering and they don't have to spend time in the hospital. We'll put this shirt in and we'll go home.
If we're able to collect ECG, EMG, waveforms, heart rate inside of a precision engine 230, imagine what we can do when we apply the fabric to a hospital gown.
More than just trying to understand my body and what's happening and helping me in the race than anything else. It's like helping the entire environment. The world is all about technology today, and that's what we get here.
Okay, so these are the applications that are introduced into the realm by the sensor device called HITO, fabric sensor device. And now I'd like to go to the other sensor device called Kokomi by Toyobo. Toyobo is another big fabric company, and they developed this new material called Kokomi in 2015. It's a film-like functional material for cloth. It's I think it's very similar to HITO, and it's used for electrodes as well as electric wire for sensors. And they claim that there are characteristics such as stretchable, it's very stretchable, and it can be stretched about double length, and it's very thin, about 0.3 millimeters, and high conductivity, and it's easily attachable. It's very interesting. It's easily attachable, so you can just iron and then put it on your shirt. So that's an economical way of creating a textile wearable sensor. I will show you another video of Toyable.
When it touches, it feels comfortable. When it touches, it brings peace of mind. When it touches gently, it communicates. Kokomi is a stretchable conductive film that simply by wearing it allows for smart sensing through the measurement of biological data. Electrodes and wiring are unified. Thickness is a mere 0.3 millimeters. Since it stretches elastically, it follows every movement of the body and always fits comfortably. High-precision physiological data measurements are possible all the time, even during vigorous movement. Based on comfort evaluation technologies advanced through the development of various functional fibers, we utilized clothing pressure simulations in the pursuit of electrode wiring that always fits the body. By combining Toyobo's unique sensory measurement technologies with various biological data, we can design products with Kokomi that meet the needs of diverse applications, including sportswear that supports mental training. We can design work clothes that detect human error. And we can even use Kokomi in caregiving and medicine. When it touches gently, it communicates. Stretchable conductive film, Kokomi.
So as you can see, it's more impressionistic, and they stress more on the comfort of the cloth, and they don't actually provide so much details about the technology behind. But and again, almost all the use cases are also covered by HITO. So use case-wise, they're very much similar. One interesting, so this is the actual shirt. This is the transmitter. And as you can see, the sensors are on the back again. And this is the actual sensor. I actually took the photograph. So it's inside, and it's on the back. And it's a lot smaller than before. This is the older version, and now it's smaller. And one interesting application is girth cover of a horse for training horses, race horses. And this was actually utilized by this company, and they sell the girth. And the reason why they tried is okay, training horses has relied on the human experience. And so they thought a scientific use of data will enhance the trainability as well as the result of the training. And wearable biomonitoring will be necessary for this purpose. But actually there are already some conventional wearable sensor devices, but they can only monitor when the horse is still or just, how shall I say, just treadmill kind of very slow movement. So they couldn't monitor when the horse is actually galloping or running at full speed. So they wanted to, they meaning the horse racing companies, they consulted Toyobo, and they realized that they can use Kokomi. So that's how they created this girth. And they actually started in 2015. Is it? No, 16, I'm sorry. Yeah, they just sold it, started selling. So this is a very new application, and I think this is the only real application of Hitomi. And so how Hitoe and Kokomi will fare with each other remain to be seen. And they say there are other expected applications like sleep monitoring, relaxation monitoring, and they also created a consortium of companies called Active for All, which promotes active life through culturalization of sports. And they include, this consortium include as members, hospitals, universities, and large corporations such as Hitachi and Panasonic. So these two are actual textile wearable sensors in use in the market in Japan. So there are a few points that I would like to propose as food for thought. One is that how can these measurement data can be shared and interoperate? Hitoe has one way of collecting data, and thresholds are defined by themselves, and Kokomi has another. So how can we make them interoperate so that we can gather data from different devices and we can compare? And do we need standard or standardized criteria for biodata? For example, relaxedness is defined by Hitoe in one way, and Kokomi will define in another way. So how can we define actual real standard for this kind of thing, like emotional or something? And then again, we have many other devices, wearable devices like smartwatch, smartphone, and even headsets. And how can these data be combined with other biodata from different devices? Because sometimes you have to combine these to monitor. And then the last question, even though they are not medical devices, if they're used along with medical devices, there may be needs for standards of quality. Because if you want to say that you're in extreme stress, then it might imply something, you have to go see a doctor or something. In that case, medical devices have to be somewhat controlled and standardized. So that's my talk. Thank you.